Okay, so the next test we're going to do is called the root test. So this test is useful only when everything is to the nth power. And so what you do is you take the limit as n goes to infinity of the nth root of the absolute value of the nth term. And then if you see these results, don't they look just like the ratio test results? They are. If the limit is less than 1, it's absolutely convergent. Greater than 1, divergent. Equal 1, you have to do another test. So this is what I mean about everything being to the nth power. Since I'm taking the absolute value, it doesn't matter what power this is. So notice this -1 has an n minus 1. It doesn't matter, but it's the rest of the term being to the nth power. All right, so doing the root test. So I would have the nth root of, and I'll just write it in here once for effect, the absolute value, whoops, don't want that there, 2n plus 4 to the nth power, right? So now I'm whoops, forgot the other absolute value bar. So the absolute value, this is gone. So I've got the nth root of the nth power. So these cancel each other out. So what I'm left with is 4n minus 1 over 2n plus 4. So the limit as n goes to infinity, so I take the highest powers. So I cancel the n's. Let me just write it so you really see it. So 4n over 2n, I cancel the n's, I get 2. Since this is bigger than 1, I know this diverges. This is another one I would do the root test for. So I'm going to skip the absolute value. I'm going to toss the -1 away. So I've got 3n plus 1, 2n squared plus 4, all to the nth power. The nth root and the nth power cancel. So I'm left with this. So I take the highest powers. So I get 3n over 2n squared. I cancel an n, so I get 3 over 2n. N's going to infinity, I get 0. So since this is less than 1, this is absolutely convergent by the root test. And I forgot, I should be saying by the root test, saying what test it is that I have a conclusion for. Okay, so these ratio and root tests, they're very similar in that their results are the same, right? We're talking about L's being less than 1 or greater than 1. You only get absolute convergence or divergence from these two tests. All right, so I'm going to start putting integrals back in. So just a quick recap of integration by parts. So u and dv, if we're talking type 1, right? So this is where you want to let u equal the x guy. Here you want to let u equal the x guy and dv equal the e to the x. And because after I do parts, I get x e to the x, very similar to this, it's better that I know I'm going to do integration by parts again. So you don't always do integration by parts on the second integral, but when it looks similar and it fits the same type of letting u equal the x term, I do. So it is a kind of a pattern. If I have x squared times e or x squared times the cosine, it's going to be integration by parts twice. Integration by parts type 2, what I called it, is where you let u equal the function you know the derivative of, and you let dv be the rest. So here you'd let u equal the ln of x, dv is just the dx. Remember, you're taking the antiderivative here, the derivative here, and then this turns out to just be the integral of 1, which is x. This one here, so remember ln, you don't know the integral of, right? You have to do parts to do the integral of, so that's why you'd let u equal the ln. Here, the dv is x dx. So remember, antiderivative, x squared over 2, derivative 1 over x dx. So putting it together, pull the one, cancel the x's, so I get x over 2 as inside the integral to take the antiderivative of, so that gives me x squared over 4, the whole answer here. All right, so being careful with functions that you know the derivative of. You know the derivative of arctangent. So dv is just dx. So v is x when you take the antiderivative. So putting parts together, you get to this. This integral here, do not do parts on again. Think about it and always try u substitution, easy u, letting u equal the denominator first before doing parts again. There's very infrequently that I do parts with fractions. So letting u equal the denominator, there's du, so I get 1 over u, so there's the answer.